Initial velocity equal to 0.
Okay.
The distance traveled is equal to minus y because it's going down. Velocity is equal to minus v. Your acceleration is equal to minus g because it's moving down. I can use the object is falling freely, it's traveling a straight line. I can use the three equations of motion. Let me use S is equal to V0t plus half AT square. I'm going to calculate, enter the password, Shiva. Press the apply. Your S is equal to minus y, V0 equal to 0, but total value equal to 0, half A equal to minus G, T is the same. Can I cancel this minus and this minus? Y equal to half gt square. I am going to get the value of g equal to 2y by t square. This is the formula I am going to use to calculate the acceleration due to gravity in today's experiment. So, coming to the data, this is the schedule. The y, the distance travel, will be printed on your question paper. You have to follow the value printed. T1, T2, T3, you may have only T1, T2. T1 is the first trial, T2 the second trial. T average, you know how to calculate the average. Yes. 3 means add 3 divided by 3. If you 2, add 2 divided by 2. There is a total time taken to travel the distance. Square this is square. So how to perform this experiment? Come to this, switch on time. This is stopwatch mode. Select this stopwatch mode. So take the ball. I think this life is short. Keep 2 fingers the back side and hold the ball with the thumb. If I release the thumb, the ball is subject to free fall. See, the ball falls freely, and if you want to measure the distance of travel starts from here and ends when it hit the pad. So the distance between this point and the pad, top of the pad, gives the distance travel. First, we have to adjust the position of the landing pad so that the ball lands almost the center. Okay. Now I can move this and make the few trail and fix it. Yes. Okay. Now this is landing. The next is I have to fix the distance traveled. What's the distance travel? If we say here 70, let us say 70. 90 for me is very height. So 70, let me fix 70. It is not 70. You have to adjust this, right? So it is about 1 point something centimeter. Adjust this. Fix this. Let me measure the length of centimeter. Sure. Good here? Exactly 70? Now, so the distance is fixed. I am going to measure the time taken to travel the distance and take this. If everything is ready, press the button. Release. Now this gives you the time taken to travel the distance, T1. Repeat the experiment for the second time. Same length. No. See, if I make the shaking here, you will not get the answer. So you should not make the shaking. Just release it. You got it. Clear? Now you can make the 2 trial, take the average and square it and repeat the experiment for various length indicated in the schedule. The next part, after collecting the data, you are going to analyze the data. Generally, we will analyze the data by drawing the graph. You are going to draw the graph y versus t square. Going to the graph y is meter or centimeter, t square second square. You will get a straight line. This is your x1, This is your y1, x2, y2. Your slope. The slope is equal to y2 minus y1, x2 minus x1. Unit of the slope, meter divided by second square. No need to change the unit. The meaning of the slope for this graph is the value of the slope, is the meaning of the slope. What is the y quantity? Y. What's the x quantity? T square. Wherever you have y by t square can be replaced by the slope, come here. G equal to 2 into y by t square. G equal to 2 into slope. G equal to meter per second square. It's the value of G. The source of error introduced in this experiment, the first quantity what we measure is the distance traveled. The distance traveled could be the major source of error. Measurement of distance traveled could be the major source of error. The next one is the time taken to travel the distance. And these two could be the possible source of error in this experiment. Clear, Shubha?
What's about the percentage of error?
If it is asked, calculate it.
Okay.